それではそろそろ始めさせていただければと思います。冒頭の部分だけ日本語で説明をして、そこから英語に行きたいと思います。今日は米国新興 AI ファンドセッションということで、アメリカで今その生成 AI を中心に注目されているところでありますけども、そういった分野に主に投資に携わっているベンチャーキャピタリストの方に来ていただいて、AI のトレンドについてお話しいただこうと思います。ちょっと最初の予定と違って参加者が減ってしまったんですけども、今日のアジェンダとしましては最初にオープニングの説明をした後に、もともと予定していたレオニスキャピタルの方がどうしても参加できなくなったということで、スティールアトラスからキャメロンさん、そしてワールドビルドからスミートさんのお二方にそれぞれプレゼンテーションをいただいて、その後パネルディスカッションということでお二人にいろいろご質問をしていくと。で、フロアの方からも質問を受けたいと思うので、何なりとお聞きになりたいということは考えておいていただければと思います。で、最後にクロージングリマークということで、BEENEXT Ventures の大久保さんの方から、今回のこういった企画が実現した背景など語っていただければと思います。で、今日のスピーカーですけども、スティールアトラスからタラルさん来られなくなったということで、キャメロンさん、それからワールドビルド、スミートさん、まだついていらっしゃらないのでちょっとドキドキではあるんですけども、向かっているという連絡があったので、キャメロンさんが喋っている間に到着されるんではないかなというふうに思います。で、特に両方とも今いろんな投資をやっているということで、どういう観点で投資をやっているのか、一方見ているマーケットというのも常日頃変化を遂げているということで、その変化をどう捉えていくのかというあたりのお話が聞けるんではないかなというふうに思っています。それではまずキャメロンさんの方にバトンタッチしたいと思います。So please take your stage.
Thank you for having me and for hosting FINOLAB, and it's wonderful to be here. Hopefully you'll find this presentation interesting. We're going to cover industrial applications of AI. And so for context, my name is Cameron Porter. I'm the general partner and co-founder of the fund called Steel Atlas. We focus on industrial technologies broadly. So these are technologies that apply to manufacturing, to construction, to supply chain, to mining, to energy production. Many of the things that the Japanese economy was built on, which is one of the reasons why I'm quite excited to be here. We invest at the early stages, so seed to early A, and we generally work with or are invested in by global industrial companies, so owners and operators of these assets. We work with them to understand their problems and then find technologies and companies that can solve them. And so what I want to cover here in this presentation is how we're seeing AI affect these sectors. And also, I think generally just how industrial technologies is becoming such a growing category in venture capital. And so in this case, this is just looking at our first funds vehicle. When we were setting it up, a lot of people asked the question, is industrials venture capital? Can it grow fast enough? And thus far, we'll see. Obviously, the fund is only a few years old now, but we're already seeing really quick growth and acceleration. And a lot of this is driven by private and public sector support, which, in the US and I believe in Japan too, you're seeing more government push to see these types of reinventions of the industrial economy. And so, to make things interesting, I'm going to give a crash course on industrials. And so we're going to build it up from the ground up. And what you're looking at here is basically the equation that will help you understand any industrial process, really no matter what it is. There's 4 components that go into it. There's the labor costs, which is like the literal physical labor of doing the work, but also the mental labor, so the knowledge work. There's the CapEx, so that's your facility, the machines, the equipment, everything that goes into it. There's the materials, so what do you need to actually make whatever you're producing? And then finally, there's the energy. If you add these up, you really can understand the total cost of a process. And then by using this equation, you can understand how technology can actually affect or lead to results. And what I'm going to do is give you a history lesson. We're going to see and look at every single technology revolution that's affected industrials, and we're going to see what kind of patterns exist, and then look at how those might apply with AI going forward. And so what we're looking at here is the invention of the steam engine. So the steam engine allowed you to stop using windmills and horses and manual power, and instead allowed you to set up these 24/7 factories. And so this was a massive conversion of labor to capital. Then came the age of steel and electricity. So this was, I guess, the period that was the Meiji Restoration. So this is when Japan's industrialization took place. And it was really the electrification of the industrial base. Prior to that, you had this is two textile facilities. You had all of these ropes and pulleys, and these were really burdensome and cumbersome. You couldn't set up your facility properly. They required lots of maintenance and support staff. To afterwards, you had these beautiful layouts, you needed no support staff. And so once again, it was a massive movement from labor to capital. And then the age of mass production. So with Henry Ford and the assembly line, and then followed by Toyota and other groups refining it, we went from production that looked like this to production that looked like this. And we eliminated so much of the skilled labor, which became standardized in machines. And if we're looking across kind of all of these trends, what we're seeing is every single paradigm shift in the industrial capital base is a movement of labor to CapEx. Now, what's anomalous about the last 30 years that we lived through is that instead of labor being converted to capital, it was only one part of the labor equation, which was the mental portion or the knowledge work. And so digitization was effective in moving that into the CapEx side of the equation. But as we've seen in prices, the prices of physical goods have gone up and digital goods have gone down. And that's because during the information age, we didn't experience full automation. And for the first time, that's changing with AI. So really what AI is doing is, unlike the last generation of technologies, it's allowing us to once again automate both the physical and the mental side of this equation. And so with the rest of this presentation, I'm going to talk through what are the opportunities and the limitations that you have to think around in order to execute on this strategy in the industrial spaces. And so what are we seeing? If you're looking at this chart here, what it's showing is how foundation models are currently used, so the models that are produced by OpenAI, Anthropic, and Google. And it's showing you how long that they can reason for or work for and complete a task. And so you see it goes from like 0 seconds all the way up to 2 hours, and completing that task with 50% success rate. What we can see is it looks like this incredible exponential curve. At some point in the future, they'll be able to do everything for anyone all the time. But the picture is a little bit messier than that. Are the models actually helping you? And so this is data from a research group called Meter. And what they looked at is they did a randomized control trial. So they were testing whether models made engineers or software engineers better at their job. And what's fascinating is that engineers who were using systems like Cursor and Windsurf, so these coding tools, predicted they'd be 20% faster at their job. What actually happened when they were put through this trial is they were 20% slower. They felt like they were doing more, but they were actually doing less work. And the real reason for that, or at least the theory behind it, is that the big challenge is these systems are not reliable enough. They don't have enough accuracy. When you're looking at this chart, basically what it's showing is, this is the task that these models can complete with 50% accuracy with a given amount of time. This is what it would be for 80% accuracy, and this would be 95% accuracy. And if you need to apply these models in industrial applications or in business use cases, you really need 99% accuracy. And we're really far away from that. And so the companies that are using these models have to try to build around this reliability challenge. What I'm going to talk through next is how companies are doing this in the industrial sectors, because this is the big opportunity. And so the first major trend in how this is getting applied is on the manual labor side of the equation. and how that gets converted into new capital assets. The key technology behind this are visual language action models. So these are models that allow you to give natural language instructions to various robotic systems. In this case, it's a humanoid. They combined a large language model or a text encoder with a vision encoder, and then have a policy action header that then brings these together and allows you to do these tasks with lots of flexibility. And what's exciting about this technology is it allows you to combine very specialized robotic equipments with more adaptable ones in order for the first time to automate full processes. And so this is one of our companies. It's called Framework Automation, and they are fully automating textile manufacturing. If you're looking at the image here on your left, this whole garment loom is a system that allows you to essentially print an entire piece of clothing. So in the past, you would have to do two sides, two panels, and then if you see on your shirt, you can kind of feel this like stitch. That was all manual labor, so someone sewed that by hand. And that's why textile manufacturing got outsourced to Bangladesh and China, where they had very cheap labor. But with this machine, actually from a Japanese company called Shimaseki, you can now, for the first time, make a whole piece of clothing with one print. And then you can pair it with these other adaptable robotic systems and eliminate all the labor. And so that's exactly what this company is doing. And this company would work in places like the US, but also in Japan, where you have high labor costs and high skilled workforces. And so this is the second thing we're seeing. We're seeing hardware complexity be converted to software complexity. So in the past, if you were building systems like this, and that's like a very complicated particle accelerator, you would need to use the most advanced magnets. You'd need to use very specialized components. But what we're seeing is that because you can use machine learning systems and AI, you can actually use cheaper hardware or commodity hardware and then have the AI systems self-correct. So they can deal with changes or errors in the hardware and correct for them while the system is operating. And the way that you do that is via systems or techniques like multi-agent reinforcement learning. So what is this? It's basically game playing. So reinforcement learning is like you have a system, it's like a Mario character, that character plays a game, it's rewarded when it does well, it's punished when it does bad. And over time through this gameplay, it learns how to do a task. And then you set up teams of these agents. So you can think of it like a soccer team, you have goalies, you have forwards, some are meant for scoring, some are meant for other tasks. And in combination with one another, they can do more complex activities. In fact, incredibly complex activities. So this is another one of our companies. It's called Transmutex, and they're reinventing nuclear fission. They're reinventing it in a way that I think is really applicable to Japan, because what they do is they power nuclear reactors with a particle accelerator as opposed to with a critical fuel. What that means is that you can't have a meltdown like what happened at Fukushima. So they're incredibly safe. If the particle accelerator shuts down, the reactor turns off. Now, what's even more exciting about this is they developed one of these multi-agent reinforcement learning systems, and they operated this full complex machinery entirely autonomously. And they're now using cheaper hardware to do it because their online system can correct and learn and deal with errors. And so if one of these magnets fails, the other magnets can adjust in real time. And so we did this just a few months ago, and the system operated for 24 hours straight on its own. And this is paving the way for fully autonomous nuclear reactors and various other complex industrial processes. And so this is the final kind of major trend we're seeing, is the transformation of companies selling just software. So you're selling a tool to someone selling a service, so a full job. We're seeing this across the industrial stack because traditionally it's been very hard for industrial companies to adopt software. They need something that can do the job end to end. And so a services company does that by taking some of these models and then doing customizations called post-training. And so these post-training customizations have two forms. There's the compile time optimization. So these are things where you improve the model by continuing its training, doing reinforcement learning with human feedback and various other techniques, or by directly doing things like few-shot learning where you're changing the prompt based on specific use cases. And you can get pretty dramatic outcomes this way. So this is another one of our companies called Hedral. They do structural engineering. And so what that means is that if you have someone that designs a building like this, you have the columns and the beams and the steel, and all these various components have to be designed manually today by someone using systems like AutoCAD. What's incredible about Hedral is they use those techniques I just described along with deterministic kind of solvers and physics engines in order to automatically generate all the structure for a building. You give it a picture of a building or a 3D model, and in a matter of days, it produces every single component of steel and concrete that goes into it. It gives you a bill of materials. Today, they're working with the US military as well as the largest data center constructors because they can build buildings faster than anyone else. And so where is this all going? Well, one of the things that's becoming incredibly clear is that we're running out of data. If we want to fuel the applications we just described, we can't just use the data that existed on the internet. That's not enough. We need to find new data sets that give us information on all these industrial processes and energy production techniques. And we need this data to be available to the next generation of model companies. And so one of the key technologies that we're seeing, or sets of them, is this combination of edge processing techniques. So you have new levels of ubiquitous networking that are giving sensors access to the internet wherever they are, via constellations like Starlink, as well as new constellations that are going up all over the world. You also have edge processing technologies like this one from Coral, which is a Google spinout. It allows you to do low latency, high throughput inference, and it does it with very low power draw. And finally, you can combine that with things like Hubble Network's low energy Bluetooth systems. So this chip that you see on that finger can operate for up to 10 years with a small battery, and it can track any object in the US in real time. What it ends up doing is it propagates a signal to nearby cell phones, and then those cell phones amplify the signal to a satellite constellation. This combination of technologies is a set that one of our companies uses called GenLogs. What they do is they track commercial freight across the US. So the company is only 2 years old, and using these technologies, they're already tracking 85% of all US freight. It's likely the single largest data set on the US supply chain today. What you're looking at in the video is just an example of how this system can be used. Say you want to find goods between two places that are capable, or trucks that are capable of moving chemicals or hazardous materials. They could be radioactive. You can basically search and say, show me all the trucks that are available between these two locations at this point in time because I need to move them. You can then see where these trucks are being seen and which one might have like the ability to carry your load. And you can go and click in, and using this like this nationwide sensor network, actually see the vehicles that are available for carrying your freight. And so this is all built on the back of these edge processing technologies that wouldn't have been possible a decade ago, and are directly what's going to feed into the next generation of machine learning algorithms. And so what we just ran through is basically all the various ways that you can take these foundation models and systems with real limitations and actually use them in industrial applications. And what we're seeing today is the beginnings of the next techno-industrial revolution. If we go back to that equation and this formula we laid out, we're seeing the dramatic movement now of labor to CapEx. But what's even more exciting about this is that, the second half of the equations, materials and energy productions, are in themselves industrial processes. And so just like the industrial process itself, these two can benefit from this level of automation. And so the companies and countries that are understanding this approach and supporting the next generation of industrial technologies are going to directly benefit from this massive change. The key thing to the whole equation, though, is having cheap, abundant energy, which is part of the reason why we're so supportive of like new nuclear policies, both in the US and elsewhere, because that's really what's going to enable a lot of this. So that's my presentation. Once again, I'm Cameron Porter. I'm the co-founder and general partner of Steel Atlas. More than happy to discuss any and all aspects of AI, especially as it applies to industrials. I think it's a very exciting place to invest given Japan's like industrial economy. So thank you very much.
Okay. Can everyone hear me? Yep. Okay, great. My name is Sumeet Singh. Thank you for having me. I'm the founder and managing partner of Worldbuild. We are a new thesis-driven investment firm investing in the future of computation. We are living through the largest technology transformation since the internet, and that's raising a lot of questions around business models, infrastructure build-outs, and ultimately where capital should flow. And what I'm going to talk to you about today is where we believe the most durable value will accrue in AI, and where to look as investors and corporates. To give you some context on our perspective, Worldbuild is a thesis-driven early-stage firm. We are currently on Fund 1 right now, which Reid Hoffman, the founder of LinkedIn, early board member of OpenAI and board member of Microsoft, anchored our fund, and we've made our first 6 investments to date. But prior to starting Worldbuild, I was actually a partner at Andreessen Horowitz, was the first partner hired in New York, invested across categories. And prior to, during my investing career, I've been an early investor in breakouts such as Revolut, the global neobank, Sardine, which is an AI fraud platform. Browserbase, I was the founding investor of, meaning I helped start the company last year. Browserbase basically allows AI agents to take action on the internet by building headless browser automation, which I can talk to you more about. And the San Francisco Compute Company, one of the most exciting companies in our current Worldbuild portfolio. Now let's get into it. Compute is the new oil. If you go back just 15 years ago to 2010, the world's largest companies had a combined market cap of about $2 trillion. And as you can see, they were primarily oil-driven. ExxonMobil, Petrobras, Shell, etc. Fast forward to today, the world's largest companies have a combined market cap that's 10x in size, so $21 trillion, and they are all compute-driven. Apple with their full stack nature and custom silicon, NVIDIA, of course, with their chip infrastructure, but also their software infrastructure and CUDA that cannot be understated. Microsoft with their stake in OpenAI. Google, of course, with creating the transformer revolution as we know it today with DeepMind, and then all the way down to Meta building data centers the size of Manhattan, where I live in New York City. And TSMC and Broadcom in this infrastructure space. Now, this isn't just to say that the largest tech companies are getting larger and larger, but rather it illustrates that compute is actually the new sort of fundamental resource that powers economic growth, much like oil did in the years prior. Now, before we figure out where value accrues, we first need to think about the entire value chain. Right, this is a new supply chain that has sort of come to light in just the last few years. Of course, previous bubbles helped us get here. Right, in many ways, we wouldn't be in this position if not for video games and even Bitcoin mining, right, getting us to all this chip infrastructure. But as you can see, right on the right side here, everything from the sort of hardware infrastructure, manufacturing, semiconductors, data centers, etc., memory, even for local infrastructure. We'll talk about why that might be important in the future. All the way through the software infrastructure layer, right? So developer tooling to make models useful, the actual sort of clouds and new neo clouds that are emerging as a way to take advantage of this wave, all the way up to your model providers across various large company model labs, as well as your new upstarts that are coming up with new techniques, like earlier this year with DeepSeek, and now other new companies using distillation to get to new models as well. Where most venture investors have been spending their time, however, is on this application layer, right? However, this is an area that we think is under a lot of pressure, and I think value will actually accrue to this side rather than this side, and I'll talk to you more about that in this presentation. So what's changing in this value chain? One is that we are in a hardware race. GPUs, high performance memory, custom silicon, every single major tech company is trying to figure out their compute destiny, right? They're trying to control their compute destiny. Where do they fit amongst this evolving landscape? It's not just about performance anymore, it's about economic survival. We are in an infrastructure crunch. We are seeing an infrastructure build out that perhaps the world has never seen before, thanks to this AI wave. We're seeing these data centers get built out. Again, Meta building a data center the size of Manhattan. What does that do? That actually ends up straining energy grids. So we're going to need a lot more energy, which I'm sure Cameron just walked you through how we might get there. It's straining these grids. Like there's going to be opportunities to help manage that, provide sort of tools against volatility, and also sort of perhaps even benefit from that volatility, which I'll talk about later. Now, what's also interesting in this infrastructure crunch is, there's a lot of talk of, hey, are we in a bubble right now? Right? We're seeing all this investment, all this CapEx. What is it resulting in? Now, even if we are in a bubble, I think something that's really interesting today is there seems to be a bit of a geopolitical floor on that bubble, in that every country right now is trying to figure out, again, where do they fit in this value chain, right? Do they need sovereign AI? Do they need their own sort of chip stack? Do they need their own model stack? And that's going to be a really interesting decade to come as we sift through this value chain. And then lastly, we are entering in what I call a new AI economy. From model breakthroughs to mass deployment, compute costs are starting to dominate everything. They're starting to dominate business models, and the business model of software is changing. The software economy that we just lived in for the last 15, 20 years is very different than the AI economy. In the software economy, you build a product once and you distribute it at a near zero marginal cost. In that, every time you use the product, right, let's say I'm using this presentation software, it doesn't cost the company anything to service me, right? Maybe besides some support costs and sort of low cloud costs. If this was an AI presentation tool, every time I make a change or request a change, there's an inference cost associated with it, right? So that's a new business model and a new change here. And that's really our core point today, which is that the AI economy is different than the software economy, right? This is a new evolving economy. And thus the question becomes, where does value accrue? And as I mentioned before, we believe that AI applications, where a lot of venture investment and activity is going right now, is under a lot of pressure. This layer, the application layer, is under a lot of pressure from multiple different forces. And I'll walk through the different forces here. On the top side, you see model costs. What do I mean by model costs? I mean the price per token that you pay every time you use an AI app. Now, the common wisdom right now is that the token prices and inference costs are actually going down, people would say. However, for the best models, the price stays constant, and customers demand the best in this race of AI. Secondly, which I think is actually more interesting, is although most people are talking about gross margins, the model capabilities themselves are getting so advanced. The models are getting better and better and better, meaning they can take on longer tasks for you, take action for more complex tasks, coordinate with one another, and actually that ends up diminishing the value of the application wrapped around that model. Now, thirdly, as these models get more complex, you will start demanding more out of that model, right? So imagine you're going from a amateur, let's say, sports player to a professional. You're going to expect more, right? And that way, that also means they're going to cost a lot more, and you're going to lose a lot more tokens. And then again, the user disintermediation, same point as the model capabilities, where why as a user would you try to use some application when your model provider or your favorite model will actually just take care of the action for you? So just to walk through each of these in more detail, this chart here shows, I know it's a little blurry here, but the point of this chart is showing that for the most advanced models, the token price stays constant. Whereas for the old models, it does get cheaper, but the customers will always demand the best models in this market. If presented with an option, let's say for complex use cases, whether it's in code generation or in healthcare, financial services, supply chain, logistics, things that are super, super critical, of course the customer will demand the best quality, right? Because it's so critical to their business. And if that's the case, then how are you going to benefit from this decreasing token price, right? A lot of companies right now, the AI applications, they're leading with subscription-based pricing, right? $200 a month, $100 a month, you can use as many tokens as you want. But when the models get better, that business model breaks. So these applications, again, are under pressure from this business model that they are taking, trying to almost take the SaaS, software as a service business model, and apply it to this AI world, which we don't believe works. Secondly, again, I think this is a little more interesting than even the margins, which is the models are becoming more capable. This is a really interesting chart that shows since GPT-2, the length of a task that an AI model can do for you has been doubling every 7 months. So we started at under, let's say 2 seconds, right? Okay, and then it breaks. Now it's come up to about 4 hours. And that's scaling linearly, right? And that's doubling every 7 months. We're gonna be in a state within the next year or two where an AI agent will be able to work on a task for 10 days, a month at a time, right? That is what is coming. Now, if that is the case, of course, their usage will also increase, right? Again, you're going to expect more out of these models, meaning there will also, if you're an application provider, again, you're charging a flat fee, you will not be able to afford that. And then again, as these get more advanced, why do you need to wrap the model? Why do you need to put a seatbelt on a Ferrari, right? Is the common saying. That's what these applications are starting to feel like on top of these models. Now, this brings us to the bitter lesson. Richard Sutton is one of the pioneers of reinforcement learning, which has led to a lot of the breakthroughs in this recent wave of AI. But AI has been its own category for the last 70 years, even pre-large language models. In the 70-year history of AI, Richard Sutton's main point is that as the general models get better with scaling laws, it diminishes the value of any domain-specific knowledge around those models. That's been the case across computer vision, speech recognition, games like chess and Go. And I believe that seems to be the case again today, where in the LLM world, as models get more capable with scaling laws, they diminish the value of any vertical workflow wrappers around them. So that's the key point here, right? The bitter lesson is that these application providers are making the same mistake that the researchers did in AI, where they try to wrap the models with domain-specific knowledge, vertical workflows, when in reality, with more compute, with more data, the general models will end up surpassing their ability. So then the question is, where does value accrue, right? As a venture investor, if the application layer, is under a lot of pressure, where then do you think value accrues and where will you invest? And where we're investing behind is what we call the model economy. And the model economy is essentially, the key point is imagine building infrastructure for models and taking advantage of a new business model here where you can sell to model providers rather than building an application with models. So again, build for this model economy. Don't necessarily build an application with those models. Now, again, there's been a new business model that has emerged here over the last few years, right? NVIDIA pivoted from video games to selling their chips to pre-training and inference providers. So they are, their business model is selling to model providers now. Crusoe and CoreWeave was just went public in the US, right? They build these AI data centers. Well, actually they were Bitcoin mining data centers, right? But they found this new business model of selling their infrastructure and selling their data infrastructure to the AI labs. And then on the data side, companies like Reddit, of course, Reddit known for their social media, ad-based business model, has actually found a new lifeline in these data deals. They sign these large recurring revenue deals with the large model labs like OpenAI to provide their conversation data for training. We think that's a really interesting new business model that we'll also talk about when we think about the subcategories in which we're investing. Now, of course, there is a question of, okay, which areas within the model economy will be durable? And in order to even answer that question, I think it needs to start with a belief, right? One belief is that we are in this multi-decade secular tailwind of compute being as fundamental to society as electricity. Like I believe every interaction that we take, going forward, if you zoom out from now, will be compute driven, right? That's one thing. And two, we'll have many models that flourish rather than just one. So I believe in a world of many, many models rather than just one supermodel. So what are the subcategories in which durable value will be created in the model economy, and what are we investing behind? One area is around we need more efficient compute and energy. These are companies that can enable scaling laws, right? Provide that compute, provide that energy, but that are built for withstanding volatility. So what do I mean by that? Just to give you an anecdote, from earlier this year, during a Microsoft earnings call, Satya Nadella at one point said, we have way too many GPUs. There's too many chips. We're in a GPU glut. 1 month later, he went on the record and said, actually, we processed 50 trillion tokens last month. We clearly do not have enough GPUs. What does that say to me? To me, it says that, okay, even if you believe in this exponential curve of everything around us being compute driven in the future, there will be lots of volatility. And so where we think value will accrue from a startup perspective, not from an overall perspective, but from a startup perspective and how to invest, is businesses that can benefit from that volatility. So imagine companies that are building energy trading platforms, and we'll talk about one in our portfolio, companies that are building GPU aggregation or almost marketplaces. This is a video from one of our companies that allows you to actually set your max price of where you want to sell a GPU hour and how much you want to fulfill, what the supply and demand ends up looking like for that market. The competitors for some of these companies are not withstanding for volatility. They're in the line for volatility, meaning they are buying chips themselves, they're using debt to do so, they're spending a ton on CapEx, but if the market shifts one way, they might be dead in the water, right? And so the types of things that we think will accrue value in this model economy, again, will be ones that support that exponential curve, but that can actually withstand this volatility. Secondly, we believe compute will be everywhere. So we are investing behind companies that allow for local distribution of models, edge hardware, and then also the infrastructure behind that edge hardware. So we're excited about in the public sector, SK Hynix with their memory providers. But then also on the startup side, new companion devices or new devices that actually allow you to run local AI models private to your network. So imagine if you're a quant trader at a Citadel or Renaissance, you likely cannot use the cloud model providers because they're not private. You don't know what is being trained on. And so, some of these companies that I'm seeing need to develop their own racks of servers, but they also need a lot of software behind that, right? How do you best take advantage of these agents and these models for your own purpose? So we think there's going to be specific devices that get built to run local AI models. Two other areas which we think where there will be durable value, where durable value will be created, is in the data world. So as models get more complex, their need for more and more complex data increases, right? As they get more complex, they run out of almost exhaust from the internet, and now they need complex data. Where does that complex data sit? Enterprises, right? Whether you're a law firm, whether you're a financial services firm, whether you're a supply chain firm, that data, there's a lot of really high valuable data in there that could be used to train an AI model. And so I believe there will be new platforms that emerge that connect the model providers with companies that have that data. And of course, it's not going to be a straightforward, marketplace. Here's a piece of data. I actually think it'll look much more like a, Palantir style model where the, model provider or someone in the middle can come in to the enterprise, help you figure out, hey, where is your data actually valuable? How do we then also get it to the model provider? So we think these new types of exchanges will emerge, as well as data capture. What do I mean by data capture? Well, historically, if you were building a robotics company or a company, let's say, built in the, in the atoms world, right, in the physical world, often it would be quite difficult to scale because you need so much CapEx to get to a breakthrough, right? You need so much capital. Meaning, as a venture investor, it's pretty hard to underwrite, right? We're going to need so much capital that we might get to a stage where our early investment could get wiped out by some later investor. Today, that might be changing, where if you are a real-world company in the built world, again, maybe building in the robotics segment or building computer vision, you have perhaps a new business line that's opened up to you, right? All that data that you're collecting from cameras, perhaps that can be used to train for models, right? Visual models, world models, et cetera. And that provides, again, this new business line, new business line that they have. Lastly, in security. Why is security interesting today and how is it different? Security historically was quite defensive, right? You have a security layer to prevent against hackers, to prevent against sort of faults or bugs or attacks. Very defensive. I think security in this AI age actually turns to offensive. Sorry about that. Okay. It turns into offensive, meaning how do we go in and figure out what are the vulnerabilities of these models? How do we figure out what can be taken advantage of so that we can go tell the model provider, hey, here's some vulnerabilities, right? Here's how you protect against people trying to hack your model with prompts or prompt engineering or other exploitations, right? So it ends up looking much more offensive. How do we go deploy into the model providers, figure out what are the leaks, the holes, the things you didn't know and expect, but people are starting to take advantage of, and protect against that from there. We believe, again, everything around us will be compute driven, right? And so, of course, we need to make sure that it's fault secure, essentially. Just to walk you through a few examples from our portfolio so far in the Worldbuild Fund 1. One of the companies that we're very excited about is called the San Francisco Compute Company. And what SF Compute for short essentially builds is, imagine a power grid, but for GPUs, where they partner with companies on this side. These are your hyperscalers, your GPU clouds, and your new infrastructure funds. So imagine, your Brookfields of the world, KKRs, Apollos. These people are buying billions and billions of dollars of chips. There's actually $1 trillion worth of clusters being set up today, whether it's from companies like Meta or even sovereigns like the UAE that are buying more and more chips. So what SF Compute does is they build software for this side of the market. They build white labeled cloud software so that if anyone in this room happens to be buying chips or happens to be setting up clusters, they will design and help you operate those clusters with white labeled cloud software. So imagine AWS essentially as a service for people that own these new chips, or these new buyers of chips, perhaps. On the other side, they then create a market. So almost a compute market, a trading market for people that have a demand for compute, whether it's for the application layer, whether it's for custom inference, whether it's for training. They create a compute market. Why is that important? Again, because in the AI economy, there is the zero marginal cost doesn't exist anymore, right? Your costs scale linearly with your usage, meaning you need the lowest cost of compute. And so SF Compute provides the actual spot price, the actual lowest price of compute. And we've signed some large deals on the inference side, we work with companies, some of the biggest inference companies in the world. And on the GPU side, we work with some of the largest new neo clouds, as well as new infrastructure funds that are being built to buy this compute. And we led a earlier seed round earlier this year, and actually they're in the middle of a Series A process right now. Our second company is a company called Truffle. This is the Truffle device, just to give you an example of what it looks like. This is a device that sits on your desktop and allows you to run an AI agent locally to your environment. They've actually also built a new programming language on top that allows you to run these agents on that local environment, right? Ensuring privacy and a new capability around infinite inference time compute. What do I mean by infinite inference time compute? I mean, imagine having this device, and because there's no cloud token costs, you can have it run on a complex task for a month at a time, right? Without the need for, oh, we're going to run out of credits, if you will, right? It can run independently on its own, local to its environment. Eventually, we see a world, and you could plug these Truffle devices into any dumb hardware device, right? Even if it's not AI centric, you can actually just plug this in, and perhaps it can take over as a smart brain, as we call it. So we're early investors in that company, alongside folks like Naval Ravikant, sort of famous angel investor, one of the founders of Solana, Raj Gokul, and a few others as well. Sorry about that. Oh. Okay. Our third company in our portfolio that I want to highlight, again in the model economy, is a company called Fractal Power. What Fractal Power does is they build these battery substations, put them in high volatility areas, starting with the Texas grid, where that's like one of the biggest states with the AI data center boom happening right now, meaning it's causing a ton of volatility on the grid. Again, that infrastructure crunch, right? For 40 years, demand for energy in Texas was flat. But now it's skyrocketing. It's causing a lot of volatility amongst prices for consumers and for businesses. And so Fractal Power builds these stations, these battery systems. They put them at the high volatile areas in the grid in Texas. And what they actually do is they buy energy when it's cheap, and they sell it back to the grid when it's expensive. And they actually settle that. So it almost ends up looking like a prop trading firm with actual energy settlement, not only helping benefit and stabilize the grid, but then also potentially making large sums of capital on that as well, as you actually almost build a trading platform here where you get liquidity from outside investors that want to invest in this new energy commodity, if you will. And these Fractal Power actually allows you to build that. That's their long-term vision, is building an energy trading platform. We just led the first investment into the company, and they're just at the very, very early stages of getting started. So that's three companies that I just want to highlight from the Worldbuild portfolio that sit at this model economy layer. Again, they're helping get more efficient energy, compute, local inference, but within Fractal Power and SF Compute's case, they again actually are able to withstand and benefit from volatility, which we think will continue to ramp up, right? We're going to be in cycles, in the news cycle every day. Are we in an AI bubble? There's too much CapEx. Oh, actually, wait. We need more investment. We need more investment. Elon Musk is building a new data center the size of a country, right? There's going to be a ton of volatility around sentiment, and the best businesses in the model economy will be built for that secular tailwind, that secular trend, but that can withstand volatility. Now, does that mean that apps are dead? I think in the current construct, right, if you take some existing workflow and you AIify it, those companies, those applications are likely going to be reduced in value because of the bitter lesson. However, in the future, we think there is room for applications, but they must start by being AI native, meaning they start with the nuances of the technology first, and then they go into the workflow. Now, if you look back in venture, this is historically how the largest application companies come to market, right? If you think about the first time you used Uber or a taxi hailing service, the reason that worked was because we had telematics on our iPhone, right? It wasn't some existing workflow, oh, this is how you find a taxi in your city or your state. No, it started because there's telematics and GPS in your iPhone, right? And that's what resulted in Uber. Same thing with your delivery apps. Same thing with Figma, which is a big design company that just went public, and it's now at $50-60 billion market cap, one of the largest successes over the last era of software. The reason that Figma started was that it was native to this browser engine called WebGL. And I won't go into the weeds too much, but it started first with the nuances of a technology and then worked its way backward to the workflow. That's how the largest successes happen at the application layer. And so we believe there's still room for AI apps, but they will have to start with the technology first. Some ideas that we think could be interesting for founders to build upon, and we invest at the very early stages, and so we're on the hunt for founders that are taking advantage of these nuances. The first is multi-agent coordination. So imagine having multiple agents from different model providers swarming up, teaming up with one another to actually then go and take action on a complex task. I urge you at home to go try this your own way, which is you can actually have ChatGPT prompt Claude or prompt Grok for you. And you'll actually see a really interesting recursive nature between those. Now at scale, imagine having, again, all these model providers coordinate with one another, have a swarm to go solve a complex task. We think there's a lot of interesting potential use cases around multi-agent collaboration. Now, again, this is also counterposition where if you are a model provider, let's say you're OpenAI or you're XAI, you're likely never going to allow your agent to go call OpenAI or to call Anthropic's model, right? You're always going to use your own. So we think this is a bit counterposition where new companies might be able to take advantage of that war that is happening essentially. Another area that we're excited about is simulations at scale. So imagine in the bio space, right? Historically, to test a drug or to get a drug to market, you need to build an entire wet lab from the start to actually even see, is your hypothesis feasible at all? Today, imagine running simulations, thousands of simulations at scale on, let's say, building a virtual cell. How does a cell actually operate? How does a cell change when you insert XYZ, either drug or changes to it? We're seeing a lot of interesting companies in the field of biology and material sciences using simulations right now at scale. And then lastly, we actually just made a new investment in a company around this, what I call continuous feedback loop. So imagine an agent that can monitor and see your supply chain or your code base 24/7. It's constantly monitoring for changes. And instead of just telling you, hey, something broke, can now actually go and fix it for you, right? By writing the code or updating for you, or taking an action on it. And we think there's something really interesting to be found there. We recently invested in a company called Interfere, which just went through Y Combinator right now. We invested before Y Combinator. But they basically are building a new observability platform in this AI native world, where they start with the continuous feedback first, not the existing workflows of an observability platform. And so, that's where we think value will accrue in this age of AI, right? The model economy first, infrastructure, a new business model that's emerged here, and then eventually we'll get into the application layer, but they have to be native to the technology. So I'll pause there if there's any questions, and thank you very much. Thank you very much.
So we'll be turning to a panel discussion now, and I would like to ask some of the question based on the presentation from both gentlemen. And first, since you're investing in the AI area, and also for us, we're in the fintech area and we have a small investment fund. And nowadays, all the startup would say we use AI. And also, the AI technology has been changing so rapidly. In such an environment, how do you find the promising startup for your portfolio? Maybe Sumeet,
Sure,
can you start?
No, certainly. Every single company that we meet, even if they're not in AI, are using AI and leveraging AI in some capacity, right? It has become a new tool, a way to progress forward, a way to be high performance. How we view companies and the ones that we're looking for are what we call native to this technology, right? They have been either researchers, they've been spending time experimenting as soon as GPT-2 came out. We just met a founder a few weeks ago, and he's like, I somehow got in front of Sam Altman early days and begged him for GPT-3 access. Like, that's the type of founders we like to work with, right? That are ones that are native to the technology, really understanding what we can do with it, how is it changing, and again, are able to keep up with what you just said, which is this is a super fast moving space. Actually, this whole presentation I put together came off of the back of that, which was this space is so volatile, right? It's changing so quickly. What we look for is people that can move with that volatility, right? That can actually increase their capabilities, increase their performance, increase their ideas, not get stuck or not get lost in that volatility. So that's what we look for. And that's actually even what prompted this whole presentation was, again, the world is changing so quickly. How do we look for, and what are we looking for in founders building here today?
Yeah. No, I think maybe to just give some practical advice or things you can look for. I think Sumeet brought up some very interesting points on counter positioning. So, how do you build a company in juxtaposition to these large foundation model businesses? And I think you'll see that the founders that are really AI native and savvy will think that through. So just to give a very practical example is, there's very interesting technologies coming to market, systems like Klein. And so what is Klein? Klein is a system where you build on top of their software, and it allows you to essentially hot swap between the various foundation models as they come out. And so if Anthropic releases a new model and it has better performance, your system can automatically, or your app can automatically use that. Or you want to optimize for cost, you can automatically swap to a lower cost model. And so you have to think about tactically, how do you take advantage of the commoditization of like the foundation model layer? And the founders that are building in this way are likely the ones that are going to build durable companies, so that they're benefiting from these tailwinds and not getting swept under by them.
And I guess since you've been investing into a different application area, and that might require not just the AI knowledge, but also you need to have certain domain-specific knowledge, how AI is used in a certain area. And how do you evaluate the effectiveness of AI in certain industry area?
So yeah, I can go first on this one. I think that if you look at the foundation models, right, they were trained on open data. They were trained on the internet. And that was like the first massive amount of data that they gathered. And if you look at the areas where these models are less applicable today, or where potentially they struggle, it's directly correlated with where they don't have access to data. And so Sumeet and both I touched on this, is that there's many valuable companies that are trying to understand where are those pockets of data. You see a lot of companies in healthcare where they take advantage of regulation and proprietary data sets. Companies like Reddit who have social media data that might be interesting and useful. But every single company that has, at least in my case, a specialized industrial process, which could be anything from how do you license and operate a nuclear reactor? How do you build a CNC machine? What is the telemetry data that comes out of those machines when they're used in different use cases? All of this is information that isn't in those public domains. And so if you can start to find ways to pair that proprietary data to develop business models that gives you access to it in partnership potentially with larger companies, those are the interesting pathways that we see founders unlocking these AI native applications in industrials. And so I think it's the key questions to ask yourself or to ask a founder is understand, what type of proprietary data sets are they offering? How are they going to continue to get access there? And how are they using them to build upon and improve upon where these foundation models are relatively weak?
Yeah, and just to add to that, as per my thesis, if you believe this sort of application layer is being squeezed by model capabilities, by the cost dynamics, again, you have to ask yourself the question of, okay, where does value accrue, right? And something that we've been interested in the vertical sector specific case is, instead of building a software app that's for your vertical specific domain, right? Instead of building an AI software app for financial services or legal work or healthcare work, what if you actually go look much more like a services business, right? Where you are using all of these AI tools and AI models, and you are an expert on that, and then you're going and deploying into these larger companies or these sort of more fragmented companies to get them to the next evolution.
Right, thank you very much. And I would like to turn to some of the challenges we face. One thing that many people point out is AI is a black box, and it's quite difficult to tell whether the result is genuine or not. And for your assessment of investable startup, how do you try to figure out the black box AI is working properly?
Yeah, happy to take that first. I mean, we've actually been spending time in that developer tooling infrastructure world around companies that are called interpretability companies. So they actually go help corporates and customers and even researchers figure out, how is that agent getting to this decision? What is the chain of thought? What are the different tools that they called upon? And if you can crack that, there's really interesting ways to then also take advantage of the models, right? If you understand exactly how they work, you can also build your advancement of what you can do with them. So actually that could end up being a core competency of the best founders here, are the ones that understand the models the best, right? They're able to build these tools to interpret them and then take that to their advantage. I think in the, let's say pre-AI, I actually started my career on the fintech side of things back in 2017. I used to work at a firm called Nika Partners, we started by the former president of Visa. And we dealt a lot with corporates, right, who wanted to partner with our startups. Hey, we're really interested in updating our loan origination software or our credit software. And it would be this battle, right? 18-month, 24-month sales cycles, because they would say, hey, we don't understand how your product is coming up with the decision for, let's say, do we give this customer a loan or not, right? That was, let's say, pre-Transformers. Today, I think we're benefiting right now from this world of just immense attention on AI and immense realization and change from these large corporates, from these large customers who are realizing if we don't keep up today, right, it might mean we don't exist. It's not just about making your performance better, it's about survival, right? And so I think actually, of course, it's still a question around what are these models providing, but interestingly, perhaps many companies and customers are almost going past that, right? And just saying, hey, we need to figure out how to use this effectively, of course, inside of our organization to be successful.
Yeah, one thing I'll just add on top of that is that, you have, I think when you look at industrials, the category that I focus on, but I think this applies elsewhere, is that you're seeing a suite of companies that are building out more advanced simulation software. And I think this is really the key, is that, we need to create digital environments that allow us to test how these new models perform. And because if you can't have an environment that can test the model as fast as the model can change and improve, if there's a decoupling there, all of a sudden we're not going to be able to deploy new systems, especially in industrials, whereby if a single machine doesn't operate as expected, you could have massive catastrophic failures. You can destroy value on an entire assembly line or destroy a multi-billion-dollar asset. And so it's incredibly important that we continue to develop the most robust simulation software stacks. We're seeing NVIDIA push a lot of that in pursuit of some of their generalized kind of humanoid robotics systems. But these physics engines are incredibly important. And so it's always this pairing, at least how we think about it, of non-deterministic models, the ones that suffer from this reliability problem, with deterministic systems. And the balance between these two is important to continuing to progress in the industry.
Right, thank you. And maybe another challenge we face is that the question of intellectual property right. Here in Japan, it was put on the media widely that some of the newspaper company have sued the Perplexity of using their data.
Yeah.
And how do you cope with that when you find a new startup?
Yeah, I mean, I spend a lot of time, at least on the AI native side, around companies that are building new creativity tools or new creativity platforms or new characters, new life engines, as they call it. And I think because of how fast this space is moving, in some ways, my hypothesis maybe is that IP breaks in this AI landscape, right? Where models are just remixing one another. They're calling each other. They're mixing IP with native IP with we don't even know what it is, right? And a model generated it. We don't know who started that. We don't know where the chain came from. Like, in some ways, our frameworks for IP are pre-AI at this point. So unless we're able to come up with new frameworks, I think our old way of thinking about IP may go away. Now, on the flip side, we spent some time with Disney recently, and CEO Bob Iger was with us, and he was telling us we're trying to shut down, right, anyone that's copying Disney IP. And so I think if you have the capabilities to do so, you will certainly go after and attack, perhaps the largest models here, or maybe ones that you can make an example out of. But the reality is there's so many open source models, right? There's a new model popping up every day. How are you going to block all of these models? It almost becomes impossible. So, I think there will need to be new frameworks, perhaps new technologies to keep up with that, rather than, hey, we're going to go make an example out of Perplexity. We're going to go make an example out of Midjourney, right? Pick your company. That, to me, I don't think is scalable.
Yeah, I think, these companies don't get built in a vacuum. And so I think it's important to always, when we're looking at IP, consider the context as a whole. And technology exists in a global context. And one of the global players in technology is China. And China has very lax kind of rules around IP and what these models are used for. And this is a challenge for the US, and I imagine for Japan as well. But what you have to think about is, in the case of a newspaper, that's suing a model creator for use of that IP, if all of a sudden your newspaper's information is not included in those models, if everyone's going to systems like ChatGPT to do their queries and your newspaper all of a sudden isn't getting referenced, who's going to be visiting your newspaper site in the future? And so this is like the real challenge, is you have to think, like, what is actually valuable? Is it the historical information? Is it the traffic that gets directed to me? What do I want to risk or make available? And that's on maybe more the consumer side of things. There's also challenges on the IP side of things that create interesting opportunities for companies. So in industrials, like you're often dealing with sensitive industries. So we deal a lot with nuclear power, but this also extends to spaces like defense, where if you're deploying a model that works in these areas, you can't just give your data to a centralized system or even put your data on servers in other countries. And so you need to develop new types of infrastructure that allows you to control that full stack. And so this means kind of operating your own clusters. It means developing your own training packages. And it ultimately means having an understanding of where your data is being used and how. And we see a lot of companies developing interesting things in those spaces.
Right. And another point, you both mentioned the cheap energy, importance of the cheap
We love cheap energy.
Yeah.
And for Japan, we don't have access to a cheap energy in a sense.
Yeah.
What do you think? I mean,
Yeah.
is the energy or the energy consumption is the key element of AI expansion?
I'll let you take it.
Yeah. Yes, I think Japan is an interesting case study that I've thought Japan and other countries a lot about. So, to give the case for why cheap energy is so important, I think it's really interesting to compare two countries and at least the pathway to how we get to cheap energy. So those two countries are Germany and the United Arab Emirates. And so what's interesting about these two countries is that both of these countries were around 20 years ago exploring how to make their economy green. So how do they move off of or away from fossil fuels and how to produce abundant energy to run industrial processes. Germany, interestingly, went the route of buying and building out a lot of solar and wind farms while simultaneously decommissioning their nuclear fleet. Now, what happened is that after 20 years of this policy, when the war with Russia broke out, all of a sudden the natural gas pipelines were cut off, and it exposed how volatile this combination of renewable power assets had made their economy. And so energy prices went through the roof. It's meant that companies are reticent to go invest there, and data center buildouts are rarer. The United Arab Emirates, on the other hand, which is one of the sunniest countries in the world, they have plenty of capital to build out whatever type of energy assets they want. You would think they'd invest in solar. As of today, though, they're 25% nuclear. In the next 20 years, they'll be 75% powered by nuclear power, mostly in partnership with the Koreans. And guess what was one of the most attractive places in the world to build data centers today? It's the UAE. And so my expectation is that countries like Japan and what we're seeing in Germany they're going to start to reverse their policies on nuclear. They're going to start to adopt systems. It could be like transmutex that allows you to operate them safely, or smaller modular reactors that have different safety profiles so you don't face disasters that have happened in the past. And we're seeing dramatic changes in the US around this regulation. We actually helped support a lawsuit against the Nuclear Regulatory Commission in the US to make it easier for companies to come to market, and that's actually going through. And because the NRC influences nuclear regulation, even in countries like Japan, I'd expect this to get much easier to build cheaper power systems here, including in nuclear, which I think would be very exciting. Because to be frank, Japan is one of the world leaders in this technology, historically.
Any thoughts?
Yeah, I would just say we've been spending some time, again, in that sort of simulations at scale type of framework with companies that are using simulations to almost like figure out, hey, what might be abundant resources, abundant materials that we thought could not be helpful at all in this energy race, but actually turns out when we, perhaps, change, one specific thing or add one chemical, it actually unlocks a new capability that we had not even thought of before. And so I think what we're excited about is like with all this investment, with all this demand and all this build out of AI data centers, that these new capabilities will be unlocked. And I think really it's about the only way that you get there is by being at the forefront of that investment, of that innovation. And again, figuring out, okay, through that, we unlocked a new capability that we didn't even know was possible before, right? So it's almost like the bubble sort of theory is like, and the bubble experimentation is actually very, very important, right? You almost have to lean in to get to that next capability, which of course is very high risk and requires a lot of capital. But clearly, again, countries like the UAE, right, at the forefront of this and now are benefiting. So.
It's interesting to see that the similar discussion is going on in the fintech or what we call Web3 world, where all the crypto assets are using a lot of energy, especially Bitcoin mining consumes a lot of energy, and there seems to be a big discussion on how to manage that. And this decentralized finance world. And I think there's certain similarity between the AI development. And another point I would like to ask you is the accuracy. I think Cameron, in your presentation, pointed out that when system development case were examined, AI was not too accurate. But if you are to apply that AI to other application, maybe accuracy might be the critical point. How do you think that accuracy of AI is changing, and also how do you think that the application need to be examined with a certain level of accuracy?
Yeah. Just to build on it, I think Sumeet laid it out nicely. Look, the models are getting better and better over time, but they get better and better in conjunction with both their ability to reason, but also their access to data. And so you need to start understanding, where do they, we've covered this a little bit, but where do they lack access to data, and where is that the crux of their lack of reliability? And the lack of access to data could show up in the fact that these data sets may not exist, and they don't exist for many things that are oriented around services. So for example, it could be an engineering task that is currently done manually today. If you do that job and you create that data set, you all of a sudden can develop the kind of edge cases and kind of all of these corner cases that really are what hold back these systems from being deployed in industrial applications. And so really what I think you need to look for is, where are the places where there's many corner cases or edge cases, and you really need to spend time in that industry or space understanding what they are to make sure the system doesn't fall over. Because that's really where you have catastrophic failures. And I think that's what will prevent likely some of these AI models from being adopted as quickly as they could be. And so companies that are taking advantage of that, and I think using that to solve the reliability problem, stand to benefit enormously.
And I also think just to build on that, I also sort of view perhaps two paths here, right? One is very interesting vertically integrated companies that are collecting a ton of that data around these edge cases that can actually use that to post-train their own models, right? So you take a foundation model, an open source model, and post-train it with your own data, right? Become full stack, and then you can also, there's sort of recursive benefit there, is one path perhaps. But again, the other might be you collect all this data for edge cases, and then you sell it back to the model providers, right? Whether it's by signing your own deals like what Reddit did, or through these new exchanges that are being set up to do so. So, just to build on top of that, we also are looking for these two different types of companies.
Right. And since some of the audience is in investment area, can you tell us how and why you started your own fund after staying with prestigious funds like Andreessen Horowitz?
Sure. Yeah, happy to go. Look, I had an amazing experience at Andreessen Horowitz. I was a partner in New York. I was there from 2021 until last year. And I had a very specific style of how I invest, which is actually how I invest today and what informs my thinking, which is I actually like to start with the catalyst first. So I spend most of my time researching what are the most interesting, nuanced catalysts across either technology, regulation, or macro that might actually be changing how new products could be built, how distribution dynamics might be changing, what new value chains are being created, where do we think value will accrue in that value chain. And so for me, that was a very specific way I had of investing, which actually brought me to the intersections of categories, right? So just to talk about some of my portfolio companies that I had on the screen earlier, Sardine was at the intersection of crypto, financial services, and infrastructure, right? For me, that's where the most exciting opportunities lie, is at these sort of intersections of categories. And the best way I thought to pursue that idea and that hypothesis is with a new firm that's generalist across categories, but uses theses like this model economy thesis to go deep into vertical specific areas. And so that was the ultimate reason to go out, depart, and start my own firm here. And again, grateful to be sort of anchored by a number of great other investors as well. And maybe just personal story, I come from a family of entrepreneurs, immigrant entrepreneurs who moved from India to the US in the 80s. And so for me, it was a matter of when, will you be an entrepreneur rather than if. So that's the sort of personal story for me. So.
Right. And Cameron, I understand that you were a professional soccer player. What made you becoming a venture capitalist.
Yeah, it's a natural path. Just one step at a time. Yeah, I mean, I had an interesting journey. I studied computer science at Princeton University, which traditionally is not the natural jumping off point to go and become a pro soccer player. But I ended up, I guess, my senior year, I was like the top scorer in college soccer and was an All-American and then got drafted. And it was actually through that time that I started to deploy some of my skills in technology. And how it came about is that I ended up, while I was playing, I got hired by the league's front office, so the Major League Soccer's league, and I worked as a data scientist and back-end engineer simultaneously. And through that, I started getting familiar with the venture ecosystem. I ended up destroying my knees, or blew out my knee, broke my leg. Once you mess up both legs, you have to go find a real job. And so I was very fortunate because of that work on the side to get to know one of New York City's really top entrepreneurs, this guy, Kevin Ryan. So he started and built a company called DoubleClick, which was sold to Google. It's what powers their ad network. He then helped build a number of New York's biggest companies. MongoDB is one of the most notable ones, the big data center provider. Business Insider is a major media company. Most people don't know these were all started by the same person. And so I was hired by him as one of the first people on his team to build a new firm focused on these technologies. As to why he took a bet on me, we'll never know, but he saw something, maybe he was a soccer fan. And anyway, it was through that I got to spend time investing generally. And I really think that a lot of the opportunities in life come from the spaces that are underexplored by others. And this basket of industrials was really ignored by the venture community for a very, very long time. And whether you look at the US or you look at Japan, industrials is the backbone of the economy. And because the information age ignored it, we didn't have our best people and best minds focused on it. And that's changing. Today I see so many young and exceptional entrepreneurs going and building in these sectors. And I didn't see that there was early stage funds positioned in the best way to support them. And so I wanted to be a part of that. I think these are the companies that are going to help stand up and support the future of nations like the US and Japan. And I'm excited with Steel Atlas to play a small part in that.
Great. So I would like to turn to the floor for a question. Is there anyone who would like to ask questions to these? Just once. The mic will come up.
I can speak quite loudly. My question is your San Francisco compute. What's the difference between this one and, for example, Together AI?
Yeah, sure. So in our view, companies like Together and others, they're using their own capital, CapEx, debt to go buy chips themselves to then resell. We think that business model is very hard because, again, we're going through, the general path here is these chips depreciate, right? That is the general secular trend, is these chips depreciate over time. And so your business model is such that you need to be reselling at a price that's high enough to make sense of that CapEx investment, which means you think you need to build software on top of your compute. But the reality is, if you're a customer, like an inference customer or a training customer, you don't care about the software on top. You just care about the cost of compute, right? Because there's that marginal cost issue that I discussed before. And so what the San Francisco Compute Company does is they essentially become a hyperscaler, but they don't use any CapEx or debt. They go partner with people that own the chips, that have the lowest cost of capital, that have geopolitical reasons to own those chips, to have other sort of competitive dynamics reasons to own those chips, build software for them, get them to 100% utilization, get them the best price on their compute, and then again, pass that through to the market. So they end up looking much more of like a market, right, and a white label cloud rather than a cloud themselves. Does that answer the question?
Yeah.
Thank you very much. Thank you very much for the session. I have one question about data. You mentioned data provider is getting more important, like data exchange or data capture. My question is, what kind of data is getting more important? Like financial transaction data is getting more important, or some data from 7-Eleven, for example, can be important. Do you have any comment?
Yeah, I think it'll actually look much more like the latter and what Cameron mentioned around these edge cases, right? Real world use cases that it's basically, that can be scraped from the internet, right? Data that cannot be scraped from the internet, but rather involves real world interactions. Where are we going next, in my opinion, is world models and these virtual models that are, that eventually get us to robotics and simulation environments. And for those to be as good as our experiences with now with ChatGPT. We need to solve for these real life edge use cases, but also there's this, in the robotics world right now, there's what's called like the sim to real gap. So this gap between the simulation environments and real environments. And so where we think sort of the most valuable data will eventually come from will be how do you figure out these, and capture these edge use cases in the real world to help go from that, or help shorten that gap, if you will.
Thank you very much.
Yeah.
And my last comment to Cameron is I was sports agent, players agent more than 20 years in the past.
Oh, yeah. Yes, we can absolutely.
Please, back there.
Thank you, Shibata-san. Thank you for arranging such a great event. A question on ChatGPT. So, Sumeet, sounds like you are saying like they're going to kill everybody. Is there any way to catch them? And how should we think about the valuation of that kind of company?
I think the general point is that the models will diminish everything. Whether it's going to be one singular model provider, I don't necessarily believe in that. I believe in a multiple model world. And so when you think about the AI app valuations right now, I do think they're quite inflated because of the usage costs that I talked about and the model disintermediation task I spoke about. So we believe that's why we're not really spending that much time in that application layer. Most other investors are, perhaps because again, they view it as the last software economy, but again, the AI economy is different. So and maybe I'm a bit, maybe a bit skeptical and maybe a bit negative, but it's not necessarily to be negative. It's, hey, I think we're experiencing these new use cases that we've never experienced before, but the question is, where will durability come from? Where will the durable moats come from? And I don't think it will be from these companies that just build on top of these models and essentially resell that cognition, right? They're not building the cognition themselves. They're just reselling it with a nice package, but that diminishes in value over time, in my opinion. And again, as a venture investor, we invest over 10-year life cycles, right? Or even longer, forever companies. So that's not really what I look for a forever company.
Yeah, I think, just to add a little bit, I think, when I talk to investors that are still deploying capital into OpenAI, I think many of them look at it as a brand opportunity. There's very few assets globally that every single day puts you in front of 100 million, hundreds of millions of people, very soon 1 billion people. And regardless of whether the models get commoditized or not, because of competition between the providers, that's an incredibly durably valuable asset if you compete it. And now you're slowly seeing the other model providers, like Anthropic, they're not really playing the consumer game anymore. They're sort of giving up. And X is the only one that's, I think, really trying to compete in this space, in part because it also owns another asset that gives it the ability to have that type of consumer intention. Same thing with Meta. They're playing a similar game in Google. And so it's really about how do you build these, like what is the next big consumer brand? What is the gateway to the internet? And I think that's the game that OpenAI is playing in so many ways. And if they want to justify this valuation, a game they probably have to win against those bigger players.
Hi, thanks so much for your talk again. And I have a question in terms of the security side, in a sense that I think it's true that those model providers, right, like probably OpenAI, Anthropic, and those models are going to be great. But then one of the key concerns that enterprises have is about the security. So when it's cloud, obviously they don't really want to although they are using API like Microsoft, even they don't really upload information sometimes, right? So do you think eventually, because those cloud models are going to be so better to the point that do you think enterprises kind of inevitably have to actually put every information into large language models, or do you think local large language models or those type of models will drive on that? Because right now a lot of company want to essentially run those local models on their local and environment as well, right? So.
Yeah, I think if I understood the question correctly, I think it today almost comes down to the type of company you are, right? Which is if you don't have tight compliance requirements around your data, I can guarantee you your employees are probably uploading everything into ChatGPT, right? They figured out, hey, this model can do my job for me. Yeah. Of course, I'm going to let it do my job for me, right? And upload sensitive documents and whatever it might be. You go to the flip side on companies that historically have always had really tight shapes around data, that their moat is that data, that algorithm, that that IP. They've had sort of very restrictive rules from day one, and so that's what's sort of forcing them to figure out, okay, how do we get creative? We want to take advantage of these models. We don't want to we don't want to not be at the cutting edge because we're a cutting edge company. So yeah, we're gonna have to figure out a way to get around that and use these local models. Perhaps there's a world, if you were asking this, like maybe we get into a give to get model, right? Where it's like you're giving data on one side to train these models, and perhaps you get sort of fine-tuned models reciprocally to your use case. That's a pretty manual process today. Perhaps with new techniques that we don't even know about, perhaps that gets faster, and that could be an interesting world that we live in the future. So.
Yeah, I think some of the problems you're alluding to are not new ones. Obviously, like sensitivity around corporate data has been a real problem for a while, and we've seen waves of this like that try to get around it, like federated learning architectures and various other things. And I think that you're already seeing architectures that start to deal with this. You have different ways of providing context to models. You can stand up your own MCP server that stands separate to the model itself. So the model is a foundation model. You have your own context like server. And as you do those queries, the two are merged together. You get the benefit of both high context from your enterprise, which can be stored, can be locally, or it can be stored on a data provider that you like, as well as access to the top foundation model. And so I think there's a variety of methodologies here. And I think what we're lucky is that a lot of the cloud, hybrid, and on-prem architectures of the past probably apply equally well here. They just need to be scaled up massively, in part because of how compute intensive these are, which is, just to talk about why we invest in the things we do, like that's where the opportunity is because we're talking about an exponential build out of scale. Like these are things where, one thing that I think about is like, it's as we go from just these models where you ask a simple question and they give a response, to you ask a question and they reason, to you ask them a question and they go perform a task. And people think that is like why that's like just the non-zero marginal cost of these models, but it's actually much worse than that because every single person is not just going to prompt a single model. Every company is going to have multiple models and agents, and those agents are going to talk to other agents. And I don't know if you've ever talked to someone who talks really fast, but that's what these agents are going to do, and they're all going to talk really fast to each other. And so as more agents get deployed, there's going to be more communication, which means more compute. And so you're talking about exponentials on exponentials. And so we dramatically underestimate these curves as soon as you start looking at these things. And so I think we have really no idea how big this will get and what the demands for power and various other things could be. And it doesn't require the models getting much better for this to be the case. So I think it's like, some of these things can be quite unintuitive, but quite powerful. Yeah.
Thanks so much.
Thank you very much.
Another question for Kevin. Sorry, since this is held in Japan, I just want to know what kind of the area are you looking forward to when you invest in Japan? Is there any particular areas you're expecting in terms of the data uniqueness and maybe Shibata-san also mentioned about the IP. Japan has lots of kind of IP which is very unique. So I'd like to know what kind of area are you expecting when you do the investment.
Yeah, I can do one really quickly. One of the things I'm pretty excited about is that this is one of the places where I think Japan is a leader. But like you go to these OEMs, so these original equipment manufacturers, and for the first time over the last 5 to 10 years, they're deploying assets with that are connected. So if it's a CNC machine, it's producing telemetry data. Traditionally, that telemetry data was maybe used for diagnostics, but all of that is flowing somewhere. And so what we're looking at is companies that are going and working with these OEMs to start figuring out how do you actually go use this data? And even in a fintech perspective, how do you use that data to better underwrite these machines? Because if you look at the depreciation curve for the machine versus the lease terms, they don't match at all. And so there's a lot of interesting opportunities where if you can build the right relationships with, I think, these equipment sellers, for the first time, I think you can start to do some very, very interesting things. And so this is one area at the intersection of fintech, industrials, and AI that I think is quite interesting to me.
Yeah, and maybe one comment on your question. I think we are in this still early dawn of this technology cycle. Like it is still really so new that the innovation can come from anywhere, right? And so, in Japan, there's a company called Sakane AI, which has come up with their own methodology and their own research on how to build breakthroughs, right? But there's others in China, right? There's others in other regions that are coming up with these new research, these new methodologies to create new models, to create new companies here. We're still so early in the dawn of this cycle that, I think innovation right now specifically could come from anywhere. So, excited about finding just the best people wherever they are.
We also have a preferred network down here on the third floor.
Okay. Yes.
Please.
Thank you for the presentation. I have a simple question about AI application, a practical application to the semiconductor manufacturing area and the process. Do you have any new findings to the AI application to the whole production area? If you can.
I'll give one that I've been looking at or looking for, but that I think is, I've actually for the first time see these companies coming out, but one of the key components to the chip supply chain are lithography machines, right? So this is what ASML does, for those who aren't familiar. It's a massive, was American, now Dutch company. And in my presentation, I talked about Transmutex using multi-agent reinforcement learning to start to figure out, how do you operate complex machinery? Well, arguably these lithography machines are some of the most complicated devices in the world. They really are, and some of the most expensive single devices. And the same teams that spin out of like CERN, the Center for European Nuclear Research, that build particle accelerators, are the same groups of people that design these lithography devices. And so the techniques that I'm talking about are leading to teams exploring new ways to make lower cost versions of this. And I think this is kind of goes to a lot of the things Sumeet talked about is, right, there's demand for the very, very high-end chips. There's also demand for chips of various levels of quality, just because the need for compute is so high. And so if we can make lower cost lithography machines, if we can start to make those more available, if we stop needing the level of skill and talent, because the engineers that are required, when ASML sends you a lithography machine, it's not just, here's the machine, like go and use it like your MacBook. You have a team of, I will tell you, very, very expensive engineers that come with it that you pay every day to operate that. Those are the things that are going to start to change. And so when I look at investing in these areas, like I'm not a chip design expert, I'm like a manufacturing process expert. The operation of those devices and how those become simplified using things like multi-agent reinforcement learning is very interesting to me. And it stands to potentially disintermediate places like Taiwan from being as critical in these supply chains as the next generations of chips come out.
Yeah, I think where I've seen sort of innovation on the chip side has been companies specifically building, let's say, chips for inference of LLMs, right? And trying to get the best performance out of those chips. I think the question you have to ask is, where in the value chain will value be created, but where will it be created durably? Which sort of parts of that stack will benefit or withstand volatility? And I think sort of general infrastructure companies like the one that Cameron is mentioning, probably have like enough protection around volatility. But if you're using as a venture, startup, just a startup, using venture dollars and using CapEx to get to a new chip architecture, you're using tons of CapEx. And what happens if the model architecture changes, right? What happens if something changes in the supply chain? What if there's a supply shock? Like, you're not really withstanding volatility, right? You're not built for volatility. And I think it's a really dangerous game as a startup to play, even if, of course, the size of the prize on the other side is massive. Most startups go through what I would call many near-death moments. And it's very hard to survive those near-death moments when you're using CapEx or debt, right? You could get wiped out and you'd have to restart, basically. So.
Okay, thank you.
You can ask last question.
Yes, thank you. Yeah, I have a question because I have a huge football fan, soccer fan.
Yeah.
Yes, and today even I have a soccer company with Wesley Sneijder.
You are?
Yes.
What?
Yes, actually. But we have been trying to apply generative AI to soccer with no success. Not analytical, all this game analysis, that's another thing. Yeah. But for generative AI, it's best for generating content.
Yeah.
But unfortunately, our soccer itself, it is content.
Yeah.
So I want to know your opinion, yes.
Yeah, on if soccer is a durable thing or?
No. Actually, yes. Actually, in my opinion, in the future, football, soccer, sports will be just a special thing. AI will generate all the content.
No, okay, here's why I disagree. Here I'll give you the bull case for pro sports. So it's pretty simple, right? Like, I will tell you, like, what if we put these chairs next to each other and we watch these chairs fight? That's not a very interesting thing. If you watch two people fight, it's very compelling. You sympathize with the people more than the chairs. And I think the thing about pro sports is not so much the level of competition. Even if a robot can compete better than a human at any given thing, it's the fact that you can see yourself as that person. Young people can do it. And live sports is one of the few areas where we'll always have that. And I think regardless of how performant machines get or whatever they may be, that's going to be a domain of human interest. I think it's why it's one of the few areas that in television or media is still growing, is because it's one of the few things that we watch live together. Everything else is disjointed. There's nothing like that. And so I think arguably, if I were to make the bull case, I'd say that, pro sports is probably a pretty good place to bet. It's probably becoming more important because it's more culturally significant. One of the few things we can connect to. So that would be my counterpoint. Yeah.
We actually have like an adjacent thesis on what I call the age of slop, the age of AI slop, right? Everything around us is compute generated, is generative, is remixed media, is remixed IP. What does that mean? It actually means that's a new form of entertainment for many people, right? Spending time generating characters and character AI, talking with them, creating media assets in Mid-Journey, all generated. But I also think there will be the reverse, right? Which is actually these IRL, in real life events, experiences almost become luxury experiences, right? And those actually retain value and perhaps grow in value as well. And so we think there's so much value in both sides, right? Lean into the new form of entertainment, but while also these IRL experiences that are very separate from your screen, right? The black box that feel like a luxury almost. So share similar thoughts, Cameron.
Welcome.
Great. Thank you very much for the discussion. And in order to conclude, I would like to invite Mr. Okubo to have a concluding remark.
すいません、本日お越しいただきありがとうございます。Thank you so much for the great presentation, Sumeet and Cameron. BEENEXT グループ共同パートナーの大久保と申します。はい、ちょっと簡単に我々のグループに関して説明させていただければと思いますが、我々 BEENEXT グループはですね、10年ほど前に投資活動をシンガポールを拠点に投資しておりまして、今現在運用資産1500億円ほどで、投資先としてはですね、東南アジア、インド、あと日本とアメリカになっております。アメリカですと、例えば、代表的な例として、ノーションがあるんですけれども、こちらシードで投資をさせていただいて、彼らの京都のチームのハイアリングなどもいろいろバリアップさせていただいた経験もございますし、あとは、東南アジアの場合ですね、GoTo グループとして上場したトコピディア、あとはインドでも、非常に多く、ユニコーンが育ってきているというところになります。で、我々今回ですね、実は、キャメロンと、サミットに来ていただいたといったところになるんですけれども、今現在、AI のファンドというものを立ち上げて、おりまして、で、こちら、まさに彼らのような次世代のファンドさん、特にですね、新興マネージャーに注目をしておりまして、サミットなどまさにそうなんですけれども、アンドリューさんを辞めてご自身でファンドを始められたと。このトレンドがですね、非常に今アメリカで加速しております。これなぜかと申し上げますと、規模が大きくなるにつれてですね、一つそのパフォーマンスを出し続けるのは難しくなってくるっていうのはあるんですけど、例えばシードアーリーステージの投資に特化したいのに、グロースレーターステージを投資しないといけないでしたり、もしくはその組織が大きくなってしまうというところで、いろいろですね、政治的になってくるっていうのもありまして、で、私実は、BEENEXT グループに参画する前は、イーストベンチャーズの東南アジアのファンドを2018年に立ち上げてまして、こちらも900ミリオンほどまでファンドとしては成長してきたんですけれども、組織が私一人からですね、実は今50人ぐらいになってまして、その中でちょっとやはりいろいろやり方も変わってきたのというところで、我々注目しておりますのが、まさにサミットでしたりキャメランのようなトップティアのファンドでしたり、本当に彼ら自身でソーシング力もあって、もうキャメラの方からもですね、いろいろ面白いポートフォリオの紹介あったと思うんですけれども、入るのが非常に難しい、そういったディールが取れているような新興マネージャーに焦点を当てております。はい。ですので、我々、今ですね、アメリカの1200人以上の GP に実はもう会ってまして、で、彼らのようなところに投資をしていってですね、で、間接的に300社から500社のAI のポートフォリオを作ってですね、なので、イメージとしては次のオープン AI、次のアンスロピックを間接的に、投資をしてですね、で、直接的に投資をして、我々の LP 様とつないでいきたいというふうに考えています。例えば、一例なんですけれども、キャメラのたちもものすごいパフォーマンス出しているんですが、あるファンドマネージャーの方、いきなり独立してですね、今まで、オープン AI でしたり、アンスロピック、Airbnb、Twitter にもうシード段階で投資をされてた方なんですけど、30ミリオンレイズしますと言ったらですね、数週間で500ミリオン集まりまして、ただ、 一方で、いや、私は30でやるからというところでですね、徹底したんですけど、その中で、500ミリオン集まっている中で我々、アジアとシリコンバレーのブリッジになりたいというところを買っていただいて、アロケーションいただいたり等もしておりますので、我々としてはですね、特にその事業会社様でしたり、我々の LP に対して AI のコンパスになっていくと。ですので、インサイトと、あとこういったネットワーキングセッションもそうですし、直接投資、共同投資、あとは将来的にジョイントベンチャー、先をですね、発掘できるような動きをしていきたいと考えている次第です。で、その中で柴田さんとはですね、実はイーストベンチャーズ時代に、一度イベントでお世話になっておりまして、で、今回彼ら、めったに日本に来ない彼らなんですけれども、せっかく昨日も来てもらってですね、2日目もいるというところで、今回FINOLABさんのコミュニティとおそらく相性がいいのではないかというところで、今回この場を借りて、はい、共同とし、開催させていただいた次第でございます。はい、本日改めまして本当にお忙しい中お越しいただきましてありがとうございます。はい